Okay, so the part 6 of the audio notes for the week number 4 is going to be mainly about the wire and the bar drawings. So you saw many of the bars around you. Some of them is going to be used in this subject to build the wind turbine shaft, for example, or definitely you see the wire around you that's used for the transportation of the electrical power. So usually these bars, the bars and the wires made by having a larger size bar or rod that's going to be simply draw through a die, and then it's going to reduce its size or cross section to have the same size of the opening of the die as you can see in this photo. So basically, it's cross-section of the bar or the rod or the wire is going to be reduced by pulling it through a die opening. So it's something like opposite to the extrusion. In the extrusion, we push the pellet, then it's going to be forced to go through the die. Here we pull the bar, then it's going to be passed through the opening of the die. Okay, just pushed instead of the sorry, it's going to be draw instead of the pushing. Although the drawing applies a tensile stress, compression also going to be plays a significant role, since the metal is going to be squeezed and it's going to be passes through the die opening. The area reduction in this scenario is going to be simply equal to the initial area or the actual area of the bar minus the final area divided by the initial area. Some drawing practice and products are for the drawing practice usually going to be performed as a cold working. We never heat them up, and most frequently used for the round cross sections, not the square one. This can be used for the square, by the way. The product is going to be the wire, the electrical wires, the wire stock, and for the fence, the coat hangers, the shopping carts, any wire that can be used for these applications. Also, the rod stock for the nails, for the screws, for the rivets, and for the springs. Also, for the bar stocks, for the metal bars, for the machining, the forging, and other processes. So the wire drawing usually is going to be done in multiple stages. So we cannot take a bar that have, for example, 20 millimeter diameter to a wire with, let's say, 0.5 millimeter diameter in one go. So we need to do that through multiple stages, and that's what you can see in the train we have in this photo. So continuous drawing machines consisting of multiple draw dies, typically is going to be 4 up to 12, separated by the accumulating drums. Each drums or the capstan is going to provide a proper force to draw the wire stock through the upstream die, and each die is going to provide a small reduction to desired total reduction is going to be achieved by the series of these dies. Sometimes the inlet is going to be applied between the dies by simply heating up the wire after relieving from the dies, and then it's going to be cooled down while it's going to be go through the drums or the capstan. The difference between the wire drawings and the bar drawings is mainly is going to be about the stock size. So the bar drawings usually going to have a large diameter bar and the rod stock to start with. In the wire drawing, we're going to have the small diameter stocks. Wire size is going to be down to 0.03 millimeters are going to be possible in that case. The machines are almost the same, okay, but the methods, the equipment, and even the terminology are going to be different. So that's a bar drawing operation. It's usually going to be accomplished as a single draft operation, and that's when it's going to be pulled through one die opening, and that's it. Beginning stock again has a large diameter and a straight cylinder shape. Requires to have a patch type operation. That's mean we're going to do each stock individually from the others. Okay, so that was the part 6, and we're going to move to the part 7 soon.